Amazing. I just have to say, what we see up there is really next generation stuff. I don't know if you really realize as I look at this, this is all real time, number one. Number two, I've heard through the grapevine that 20 to 30% of that is gameplay. So what we're dealing with here, I believe, is something that is really next level stuff. And I count myself as very fortunate to be able to moderate this panel. My name is Miles Perkins. I'm the Director of Client and Industry Relations in the M&E space. And I would like to introduce a wonderful panel. So please put your hands together for Marianne Hayden, Marco Brokvik, Chad Vernon, Dave Baldwin, Brian Karras. Yes, yes. So I want to start this off. I'm going to ask a few questions, and we're also going to, throughout this course, we're going to have a few explanatory comments that are going to happen where some of my colleagues from Epic Games are going to do a little bit of a deep dive. But I want to start with you, Marianne. The performances. Oh my goodness, right? But I can just imagine that just even going into this project, I mean, how did you go? I mean, what were you expecting to be able to do here? Because it's really, I mean, I'm feeling like this is next generation stuff.
Oh, it totally is. And that is what we were expecting to do. Going into the project, it was, can we do this? And we've been able to capture the essence of our actors and their true performances using this tech from 3Lateral.
Yeah. I mean, that because there was a moment, I think, when Azuri, when he looks and he says American, and he has this kind of, he scans him, and it's something that, to me, it comes out very clearly in his performance, but I don't think I would have gotten that necessarily from someone actually hand animating that.
Right. We're not splicing and dicing these performances. We're capturing them on the stage, and if we need another take, we'll do another take, but we're not going to ask an animator to create a different acting choice.
Right.
That has to come from our performers.
Right. And then also the other thing that I'm kind of curious about in this whole thing is, again, from that creative perspective and you guys coming into this, I mean, how did you knew that you were going to use Unreal 5.4, or I think you maybe had an idea that you were going to be marching in that direction with us. But, this bridging this gap between something that is really cinema, or meaning not cinematics, but film cinema, and a game. I mean, how did you guys come into that? I could imagine the huddle where it's like, okay, guys, we're gonna do this together.
I mean, we're shooting it in similar ways that we've done games before. It is shot more like live action, and we're not storyboarding. We're going to the stage and we're shooting. We're using a virtual camera on stage and looking at what our compositions can be, and then we're editing it later in post.
Right. Okay. Chad, I have to say that, when you start to look at these things, I think about everything that you have to consider when you guys are going into this in terms of, okay, this has to be able to be a game that can be played on such and such a device and all this. So there's a lot of considerations. And one of the things that I think about sometimes is just because you can doesn't mean you should. Can you talk a little bit about that pipeline and how you guys approach this to be able to deliver something like this that is so kind of timely?
Yeah, I think it all comes down to what Amy mentioned this morning, how she's been sort of chasing this dream of having an interactive cinematic experience, and that's sort of how we approach sort of the three layers of how we approach all the content. Is you can make a cinematic image, but then how does it look when it moves? And you can make a cinematic video, but then how does it look when you're interacting with it and the player can do whatever it is a player wants to do, and that still has to look cinematic. And then you have to get it all running on an actual production machine that players are going to have. So I think it's a balance between all the tech that's been introduced this morning that allows us to sort of implement a deliver what Amy is looking for.
Yeah. And I mean, again, I noticed the visual vocabulary, right? We have a visual vocabulary that we're used to in film, right? And it's built, and it evolves over time. And it's these things where we know that, okay, when we get into an action scene, we have a certain expectation of what it's going to make us feel like. But again, it's always evolving. Same thing on the game side, though, right? And on a game, there's also a visual vocabulary and a kind of feel to everything. How are you dealing with that? Because again, this feels very different in how you're engaging with something that, like, I'm still having a hard time understanding what is gameplay and what is more of a cinematic here.
Yeah, I think that's sort of the goal. If we want to hear people say, "Oh, that looks good," but then if they say, "Oh, for a game," then we want people to say, "That looks good," period. And we have heard people say, "Is that cinematics? Is that gameplay?" And luckily, you know, as Miles said there, through the grapevine, like, probably, we'll see.
Cannot confirm or deny.
But I mean, it's just sort of like if we can balance of you're actually playing through this cinematic, but it's as much fun to play as it is for people to watch, then that's sort of the dream that we're chasing.
Yeah, I mean, I have had the honor of being able to see it quite a bit, and it doesn't get. I'm not tired of it at all. I want more. So I think you guys have done a wonderful job there. And then the environment also, and Dave, I'll address this to you.
Yeah.
It's so rich and full of just, it feels like every nook and cranny you can get in there and do something. But stepping back, I mean, what is, I mean, even what we saw here and we saw in the demo earlier today, there's so much there, but I just have this feeling that that's not it.
Oh no, I mean, so to get the grounding and the reality of the cinematic feel that we're going for, we're actually going out and scanning, you know, big things as the size of mountains down to like things that are like you see on the desk. And so we're scanning those things because you get those little bits of detail that you can't get otherwise, or they're really hard to achieve when you're just hand modeling and sculpting and painting. So not to say that there's none of that going on, but it's, you know, definitely helps ground us in that world when you see those details that are really hard to like capture with traditional 3D kind of modeling techniques. So this is like, I mean, it's definitely new for me, going out and scanning stuff and bringing it back, and then just seeing how well it just jives together, and you're able to create these spaces that are they just feel more realistic and more believable, and it, you know, it shows, I think.
It shows, but then I'm also trying to figure out how all of that is going to fit into a package and run it real time.
That's a very good question, because that was one of the biggest things we ran into, where we started scanning these objects, and we had, you know, desks, these beautiful French desks to fit in the space, but they were like huge on disk, and we're like, this is a new thing for, you know, for me specifically, in the sense that I'm used to using, you know, polygons on screen was usually my bottleneck that I have to always adjust to on a constant basis. Now that's not so much a thing.
Right.
Now it's disk space.
Right.
So that's the next thing, and I think definitely the stuff we've been working with Nanite and the new stuff you guys saw this morning, it's going to save our bacon.
Right.
When it comes to disk space.
Right. Yeah. And the other thing that I was kind of seeing in there, in that, you know, as we started to kind of layer upon layer, it felt like you have everything within your world and you're instancing things, right? So
Yeah.
how are you able to do that efficiently? Because again, in a film environment, you don't have to be efficient, right? You don't, by any stretch of them. Well, you got to get it to work one time so that it can print one frame, and then you worry about the next frame, right? But here we are running at, you know, whatever you're going to run at on this game.
Have to pay attention to what the player could potentially do. So they could, you know, look in the direction we don't want them to. So the world space does still have to be 100%, you know, 360 degrees grounded in reality and looking good.
Right.
So that's one thing that sets us a little bit apart from, you know, film, in the sense that they have a shot It has to look really good. We got to do 360 degrees looking really good.
Right. Well, okay, so the other part of this, though, is I'm just thinking about as you're building these things,
Yeah.
are you seeing them? Are you, I mean,
So, yeah.
because it's so complex until it's, I think of music where people talk about, oh, let me put a little sprinkle here or a sprinkle there. It felt like you were putting little sprinkles here and there, but how do you do that without, are you seeing everything? Or
Yeah, I mean, it's all in editor, so it's really easy to see all the I call it cowbell, what we do, because every level needs a little bit more cowbell.
Right.
So the idea is that, bringing all these scans in, and then on top of that, Lumen, which is really awesome because we don't have to, I can move a section of the level around. I don't have to wait for a rebake. I can actually just see it, the lighting, how the bounce light's going to work, and, it's amazing in that sense because it makes my life a lot easier, and it makes all the rest of the artists' lives a lot easier as well. One less thing they have to worry about.
It does help getting levels stood up quicker.
Yes.
A lot of times they'll put in the raw scan just to lay things out, see how it looks. We just have to make sure you have a good pipeline to not forget about it. Because you want to capture, oh, there's a 30 million triangle cabinet sitting there.
We've done that a couple times. Yeah, where we've got, actually, sometimes some of the scans we get in there, the raw scans, they work great at a distance. And we'll put them in the distance, and then, Tobias, the art director, will come by and be like, oh, bring that forward. And we'll bring it forward. He's like, that doesn't look good anymore. Put it back, put it back. It's like, yeah, it wasn't meant for that close, but that's okay. We'll get it there.
Right.
But yeah, it's going from scan to actually putting it in engine, and the iteration time is so much faster now that we have accidents like that where we have these really good-looking raw scan data, and it's easy to forget that that's raw. It hasn't been finalized, hasn't been polished yet.
Right. It must be fun.
Oh, it's so much fun.
Well, with that, one of the tools that you were able to kind of put your hands on was the nanite tessellation.
Yes.
And so this ability to really layer upon layer and create things. I don't want to say out of thin air, but just about out of thin air, real geometry.
It almost feels like it. That's for sure. Because something I've always dreamed about is having a texture that generates the geometry on top of it. And now I was at the time way back when I was thinking just like plants and things like that. But this brings that to a whole nother level.
Right.
Where I can actually build a layered graph and build each piece on top of itself, and it flows, and actually the geometry works as you're building it up. So like the snow between boards on the planks on the bridge, now all of a sudden snow is going into the crack and it actually fills it in. So it's not just like a texture on top. It's actually, there's not a gap anymore. It's filled with snow.
Right.
And it's not just about adding more detail, because nanite, can already handle millions and millions of triangles, and while more triangles is always welcome, it's more, in my eyes, it's more about just iteration and workflow. So, for example, if you were there this morning, you saw some rocks that had snow on it. So the previous static workflow would be to take that out, model snow on top, put it back in. If you don't like it, go back and forth. And then if you want variations on that, you would still have to go back and forth, and now you have maybe 3 or 4 or a handful of copies of these rocks that are basically the same with various dirt or whatever on top. But with the tessellation workflow, you're basically just staying in editor and just editing materials with your one static mesh. So you're not bloating your disk space with multiple nanite meshes. It's all just in editor and in materials.
Well, we're lucky to have someone on the stage that seems to have dreamt up with this whole scheme. So Brian, I have to say, pre-release of nanite and lumen, you were talking about thousands upon millions upon billions of triangles, and I do want that shirt, by the way. But I'm curious here, why do we need more triangles?
So nanite is really good at being able to draw tons of triangles, very tiny triangles. But as we're already kind of talking about, there are cases where that Nanite is capable of rendering smaller and more triangles than are necessarily there in the scene from that camera view at a time.
Right.
So I thought, well, I'll just make my own triangles. I'm going to make some more. So we added on this tessellation feature to be able to take a Nanite mesh and tessellate it further than what it's already at, to try to handle these cases like that, being able to procedurally put on snow on top of sandbags,
Right.
to be able to take lower poly or very high poly models, but when your camera gets close enough to it, those triangles eventually, you run out of resolution at some point. And with from what we were already talking about, that there's not a constrained camera. We can't just set up these scenes for exactly one particular view. The player will be able to get closer to things and be able to see. And you don't want to have the resolution fall apart. But like kind of going into some of like how this is done, to compare this to some features that
I'm going to tell people, this is going to be an explanatory comment here. So he's going to do a deep dive here, so hold on to your seats here. Take out the notepads.
So we've shipped in past, this is back in 5.2, I believe. We shipped the feature, it's static displacement. So you can add on a displacement map in the Nanite properties for a static mesh, and it will take, in this case, this is a wall from Fortnite, what was originally a low poly wall mesh, and this wall was just like a flat plane. It was just a quad. And this, with the displacement map that was put on top of it, this feature will tessellate up, adaptively tessellate, and put the triangles where they need to be to turn it into a fully 3D mesh. But the downside there, like, it's really nice from a workflow point of view, but the downside is that you need to create and bake out this mesh of that wall plus this displacement map, and that exact variation needs to be stored as a Nanite mesh out on disk. And every time that you're going to make a different variation, say you want that wall section with a different displacement map on it, you have to create a different Nanite mesh that's stored out to disk. And as you can see, like, it's putting the triangles where they need to be. But this is, these are some sort of like low frequency details. There's a lot of flat surfaces. But if you would get out to a surface like this that we're seeing in their game, the frequency of details here is just kind of extreme. If you would take this entire like ground section and just stored it as one big unique mesh with all of this pre-tessellated out, it would be just impractically large. So instead, we'll take the approach of dynamically tessellating it at runtime, that frame, for exactly that camera view, and putting the triangles where they need to be according to the camera. So what's actually happening here, what you see here, this is a coloration showing the patches. So these are the original triangles of the mesh, and then displaced. You can see the triangles aren't flat here. Now, normally, hardware tessellation that was introduced in like DirectX 11, we had support for this back in UE4. Like, you guys may have already been familiar with a dynamic tessellation sort of feature. That might give you triangles down to this sort of scale, and even this, like in this example, the UE4 tessellation feature wouldn't be able to even get you this far because it kind of caps out in the sort of detail that you can get. But with Nanite tessellation, we get down to this scale. We get down to triangles that are, they're only like 2 pixels big, each one of them. So it's far more extreme in the sort of density than anyone's really has been doing for tessellation in real time. And it means that we can have these sort of really detailed displacement maps and get this sort of fidelity without seeing like weird morphing or any sort of like strange popping or crawling, because the detail is so small that you can't really see that. It's kind of following the same principle that Nanite has been doing with its level of detail, where if the differences between any of these sort of changes are small enough, you just can't see it changing at all, so it looks completely stable. So how does that really work? What happens there was when we take one of those patches and we figure out how big it is, what sort of shape it is, and we pick from a library of pre-tessellated little meshes that we can replace that patch with. And which one we pick will be based on how long all of the 3 edges of that triangle patch is. So here's an example where We've got over on the left-hand side, we've got an edge that's 4 long, another 4, and then 7 long. So it would pick that pattern to replace it with. And depending on what shape it is and how big it is, we can replace it with a little mesh, and then that will be displaced along the direction of the displacement map. But the problem comes is that we can't store out every single sized triangle going up to monstrously big. So what happens then? What happens when we run out of these little pre-tessellated patterns? So we'll just take one of these and zoom in on it. And this is the sort of case that you get where it's just we don't have a pre-tessellated patch that can cover something that's this big. So we solve it recursively. We'll take it, and then we'll take one of the triangles of this mesh and replace it with another one, and replace it with another one, so on, recursively, until we get down to triangles that are as big as we want them to be. And what you're seeing here in this demo was down to triangles that are approximately 2 pixels big. That's something that you can set, but at that sort of level, we can hit the sort of performance that we're looking for, as well as the quality bar. Last thing I want to touch on is something that we've kind of hinted at, which is the sort of space savings that you can get just compared to the typical nanite mesh. So on the left side here, we've got a nanite mesh that's 3 million triangles. This is like a Quixel Megascans rock. At 3 million triangles, we've got a lower poly version of the same rock that's only 24,000 triangles. And we can apply a displacement map to it, use this dynamic tessellation feature and displace it. And for essentially the same sort of visual fidelity, you can get like over 6 times compression. I should note that it's not necessarily going to be completely equivalent in terms of performance. Nanite is very fast and is highly efficient at what it does. So this new tessellation feature comes with a bit of cost, but it also comes with a lot of other improvements in the form of disk size savings and flexibility to do things that you simply couldn't do. So it's another tool in your toolbox to be able to approach problems where in some cases you might want to do the left-hand side, in some cases you might want to do the right-hand side, in some cases you have something that you couldn't even have a choice there because you simply couldn't do it without this new tessellation feature.
That's really cool. I actually want to add on to that a little bit, is that, yeah, we're already essentially baking out our height maps when we're using them to do the blending of the material work. So we're already paying for that, essentially. And now we can do it on our one-to-one models, like that really fancy, French table that I was talking about. We can now take that model, reduce the polygon count, use the height map that we already have for it, and make it look even better than it did when it was just the regular nanite and it was already too heavy, which is awesome. So I'm very excited about this tech.
Another thing to mention is not just the compressed package size, it's like the actual art file size that you're working with, which is sort of like the raw, whether it's in OBJ, if anyone's using that, or the FBX, or the Maya file, or the ZBrush file. Like when things are millions and millions of triangles, it just slows down iteration speed with artist speed, with iterations, trying to open up the file, import it back in. So if you're just working with lower res geometry, it's just like everybody's lives is just easier.
Yeah. Oh yeah. There's been many a times where I've had to open a model that was, for the original nanite stuff, and had to like make a change, and it's like click. Okay, there it is. Yeah. So
Right.
We can make Unreal render this stuff faster and handle this higher detail, but we can't make every other application run faster too, necessarily.
Well, I mean, I have to say in that context, though, again, going back to seeing how fast things are changing and how fast that this is just becoming a technology that just is and getting better, and these edge cases that you're talking about, starting to identify those and solve those problems. I mean, just kudos to the team and the creative forces behind pushing this. So, I mean, I think it's pretty amazing to see us start to solve some of these things. So, and to that point, what we also saw earlier was the volumetric, so the heterogeneous volumetrics, which I mean, just looking at that and starting to look at the details that you have in there, and again, you know, understanding that, as Kim said earlier, what did he said? It looks nice from afar, but far from nice.
Yep.
And I think that's really the case in this. But Dave, can you talk a little bit about being able to add things like this into the environments that you're creating?
Oh yeah. I mean, preaching to the choir here, but that's a huge win. Essentially, you know, the VFX, you know, industry as a whole, when it comes to video games, one of the biggest requested things is taking, you know, 2D sprites and trying to make them into 3D volumetric looking things. And that, you know, it can hold up for the most part, and, you know, we will still actually be using it. Like, you know, like you said at the very beginning, you know, you don't want to use just because you can use something doesn't mean you should use it.
Right.
But where it matters, this is going to be, you know, this is essentially what we're going to be leaning on. And it's great because you know, you can take the VDB files, bring them in, put them into the sparse texture file format, and bring them into this volumetric system, and it just works, and it looks gorgeous.
Right.
And it's just, and it gives us that next level of believability that's really hard to capture, you know, with traditional methods. So this is like, we're going to be using it probably as much as we can within reason, of course.
Yeah.
But yeah, it's going to be amazing.
Well, I always also, you know, like matte paintings that are in film, right? They would always, like, in order to kind of trick the eye to make you really believe something is believable, you put a little bit of smoke or a little bit of something that is the little bit of movement that is giving your brain the ability to go, okay, yeah, well, that's plausible.
Oh yeah, I mean, that's what VFX do to the environments, is they breathe that life into it.
Right.
And when you have something as realistic, and, you know, just it's showing the volumetrics of the smoke itself and the fires, and, you know, that makes that space more believable. And it's one of those things where, like, if you think about it, in video games, the better looking the art is, the less you pay attention to it.
Right.
The less you know, if there's something wrong, it might be something you don't necessarily know what it is.
Right.
And on that point, the volumetrics is adding to the scene, but it's also about the scene applying and integrating well with the volumetrics.
Yes.
So, like, for it to sit there in the scene and not stand out, it needs to get
the lighting.
It needs to have lighting applied to it. It needs to be able to have shadows be able to cast onto it, for it to be able to cast shadows onto itself, for it to be able to cast shadows onto the world, for it to composite correctly with those other sort of particle effects where you still have sort of traditional sprite-based particles. You need to have that, like, sort and integrate properly, integrate with other volumetric, like fog that might be in the scene. So that's a bunch of the work that the Unreal team has been working on to get this to really look this good.
Yeah.
I will say, though, just to be totally honest, this is early days for the volumetric feature. This is something that we first approached from the sort of virtual production and film use cases, and we've been trying to, like, see how we can get that into real time and like game contexts. And seeing this for the first time in these sort of use cases is really exciting. And we'll just have to see, like, where that can be used, and just from the, not from the, like, breaking point of view, but from the performance point of view, like, where can it fit into budgets without breaking the bank?
I think that's also an important theme, I think, for everyone to understand in the context of looking at the tool set, is that understanding that there is an experimental phase, and then there's something that is more kind of something that is a little bit more of a service, like you're really going to have to give your developers get in there and really work with it to make it work. And then it turns into a product that you just take for granted. And we're going to talk about that a little bit more in a moment, but it's one thing that I notice is a theme, and it's also something that people, I think, developers can expect, right? And if you're brave enough to jump in there on the ground floor, amazing things will happen, especially as we start to get feedback, like we're getting feedback from you guys. So I mean, just thank you guys for being brave enough to jump in with both pioneers.
Yeah, living on the edge, man, it's fun.
Yeah. So with that, I want to kind of transition to the next part, which is just, okay, I had an awkward moment because like we had the actors that were sitting here, and I just felt like I knew him intimately because you could look at his face and the pores on his face, and I'm just like, yeah, it was an awkward moment for me. But why is that so fantastic? Like I'm having a hard time really understanding that this is a game. And to be honest with you, it looks better than a lot of the digital humans I see out there in other stories. So can you tell me a little bit about the process that you have? Who'd you work with? How did it go down? And is it a lot more, or like, yeah, what went into it?
So we worked with Three Lateral, and we spent a lot of time on the beginning side of it and our scanning, making sure that we captured not only like their true essence and like what their digital look will be, but making sure that when we did our captures, their performances, their characters were coming through, not just so that we can replicate like exactly what they look like. Their faces need to be able to move the way they're going to move their faces when we go and we shoot something. Right. So, for example, we use, when we're scanning, we use panagrams, and these are like nonsensical sentences that put a bunch of words together that once they're in this sentence, it moves all the muscles in the face so that we get every single combination possible. So like one is the hungry purple dinosaur ate the kind zingy fox, the jabbering crab, the mad whale, and started bending and quacking. It's like, right? And so we ask our actors to say these sentences in like 6 different emotions. Mm-hmm. So you say it really happy, you say it really sad, you say it neutral, and we have them do it in character. And if they have an accent, also in that accent, because different accents will put sound and move your face in a different way. And we need, in those scannings, we need to make sure we cover all of that.
I mean, and so when you go through all that, but you also went through all the performances as well. In past, I'm aware of just trying to create a couple, 30 seconds, a minute of that kind of performance is going to take a good amount of time for a team to do, but that was a lot of animation that was up there, and I'm imagining that in the game there's way, way more.
We're going to have hours of it.
Right. And so, like, how long is it taking the team in order to deal with any one of these captures? Or
so the trailer that you saw, and then if you were here earlier this morning, we had an extensive scene on the bridge with Captain America and Black Panther. If you take those two combined, we have about 83 seconds of facial animation. A few years ago, that would have taken, a handful of animators, probably 3 to 5 weeks of facial polish. We only spent 5 days of facial animation polish on that, both of those.
That's amazing. That's phenomenal. Because, I mean, like I said, the performances were spectacular.
And Amy mentioned this too this morning. The Black Panther scene on the bridge, no animators did any adjustments to his face. That's pure capture.
Yeah.
We didn't need to go in and push any of his like smiles or smirks or add a blink. And if you add a blink, it's not going to seem natural.
Right.
It needs to come from the performance.
Right.
And that's just testament to the tech.
Yeah, I think a lot of that is just major props to Marco and his team is just delivering that rig. It's almost drag and drop into the projects. We got the rig. As soon as we put animation on it, we see it and we're like, oh, well, I guess we're done. I've worked on sort of performance capture movies in the past, and I'm just used to, you get the rig, maybe you're in something like Maya, you're working in something gray shaded or diffuse shading, and it takes weeks to animate it, and then you finally see a render, maybe a few weeks after that, and you're like, all right, well, there's what it looks like now, and now we need to tweak some things. But this one was just like, oh, I guess we could just see it fully rendered and animated, and we don't have to do much.
We're a really small team, too. So if we have to spend a lot of time polishing all of the facial animation, like we'll never finish this game.
Right.
Right. So having that ability, we can focus on making our heroes seem like supers because,
Right.
you know, Captain America and Black Panther, we were going to need to adjust other animation, you
Yeah.
know, their body animation.
Right.
And then we can let their performances just come through on the captures that we get on stage.
I'm struck again by the scale. You know, I mean, that's one thing that I feel like we're starting to see with some of the tools, whether that's software, hardware, whatever it is, that we're starting to get to a point where that technology that supports the art is really supporting the art. And I'm not just talking about you guys, I'm also talking about the actors, right? Carrie and Drew, also that this technology is supporting them in a lot, because I mean, realistically, there've been other things that I've seen where an actor has done something that translates over to a digital character, and if the animator had done that thing, they probably would have been fired because it was just such a weird thing that they did. But the actor, being that they authored it, everything that comes after that movement, you know, again, I spoke before about how he very quickly looked Drew up and down when he said, you know, American hero. And he looked at him and it was just like, I mean, that you get from a person who is really, really good at their craft. And so, I mean, I don't know what you think about that and how that, because again, going back to the first question, coming into this process, I think in the past we just think, oh, I'll fix it in post, I'll fix it later in dev, I'll fix it. But you guys didn't take that approach.
No, I mean, we're a story-driven game, right? And so we want our story to be told with our heroes. And if we don't get the performance that we want on stage, we're not going to ask an animator to create a different acting choice. Well, if we need to, go back to the stage and recapture it.
Right, right.
It needs to come from our actors and the direction that Amy is giving them.
I will say, though, that is also a testament to a really great team that can have a plan and execute on a plan, because that's not always the case. So, I mean, there is also, again, taking my hat off to you guys also, that's not, like, it really isn't always the case. A lot of people want to rely on the technology to deliver, but you guys came in with a plan and you've been really true to it. So, Marco, we've been talking a lot about all of this, and we've seen our metahumans step onto the scene. We've seen them, we are even seeing them now in UEFN, which is crazy to me to think about that. But how did you make this look so good?
Yeah, well, it's not just about making it look good, so like pushing the quality bar. It's also about making it accessible to people and everyone, so pushing that bar of how easy it is to get results, right? And like what Marianne was saying about making sure that the performers have the ability to, you know, really have their performance translate. It's about sort of removing the technical obstacle and just letting the art happen, basically.
Right.
And I think we have this sort of mentality of feeding back what we find and what we do with our partners into our process and making sure it gets better and better and better. So like Marianne was saying about how it's very important to have these panograms and things, and we also like to capture a little bit of their performance as well. So you really capture their like, you know, the essence of how, like, everyone has their quirks and you know, they move their face in a certain way, and like, you want to capture that right at the very beginning. You don't want to start thinking about that at the end of the pipeline. You want to do it at the beginning so that it all translates throughout the whole pipeline. So we capture a lot of data to make this possible, and then we do a lot of R&D to create these tools, and then we start using these tools. And that's like the three lateral services, basically the arm of the MetaHuman team that tests our tech, right? It makes sure it's robust. We do our demos. You know, we had the Blue Dot demo last year, and like we learn, and then it goes back, and then we develop, and then when it's ready, we partner with amazing like artists, and I absolutely agree that when you put it into the hands of other people and artists, like they do things which we didn't expect, like, and then like all right, so that's a challenge we need to deal with, and then it goes back again. It can even change the type of data we want to acquire, and then it goes through the R&D again, create more tools, and then
So again, that's that kind of R&D, and then there's the kind of services where you're working and really working out all of the details, and then it shows up kind of in the product.
And
that
in
is
the end,
right.
it goes into the product, and hopefully, like the public gets a chance to have a whack at it, and then they do things with it, which are amazing. And like, okay, what about these use cases, which is really really amazing. And like, you guys used the ML rig, right? Which is like the highest fidelity, like high-end asset. But
Thank you.
yeah. But then there's like UEFN, where we have lowered that bar so that everyone can use these rigs, and the underlying tech, you can use MetaHuman Animator with those. So it's not about just pushing the quality; it's about making sure that we democratize the tech and everything.
So before you get into your explanatory comment, which you're about to dip into, I mean, and maybe this is going to be a part of that, but this idea that you just had is that kind of the MetaHuman 1, the 12, the 15, and the 4D. That's kind of what you're talking about here, right?
Yeah.
That level of fidelity that you're putting into the model, and that is then coming out of the backside, right?
Yeah.
Yeah.
So like basically, if you look at our history, you can see like what we went through and like the evolution of the metahumans. And as time goes by, we basically try to make available what was cutting edge, and like we try to make it as easy as possible for people to use. We try to get it in the hands of like the public and our partners, and then we see what they really want. We learn from that and then push in that direction, because the space is infinite. Like you could develop in all sorts of directions, but you want to like see what people are actually doing and try to push that way, because you have limited resources. So for instance, if you look at the MetaHuman creator, you're just using like your artistic eye, and everyone can do that. Open up the MetaHuman creator and create a rig, which is like, you use a reference basically, but then you can use Mesh to MetaHuman, which uses one scan, and you're basically now calibrating the rig, right? And you have that neutral scan, which you have the fidelity of the person in your rig. But when the actor starts acting, or you start acting, you might get a smile which isn't exactly your smile. Maybe your jaw open isn't quite as wide as the rig you get. And then you can start going even further by adding more scans. And this is like what we were talking about, MH1, MH12, MH50. Basically adding more scans, adding more data into the rig will calibrate it further and capture more of the person and make sure that like it's truer to whatever you're doing. Right now it has your smile, now it has that wink you do, right? And then you can use 50 scans. That's like covering most of what your face is going to do. And then you can have 50,000 scans, which is basically the 4D, and that's the ML rig. And with the ML rig, it's not just about capturing the expressions. Then it becomes about capturing those nuances of the performance, right? Because at that point, you're getting those ticks, you're getting those like subtleties, which like you said, like him looking up and down. You might not get those kind of details with just 50 or 70 or 100 scans, but like, and that like processing 50,000 scans is not easy, and like it's not something you could go through and sculpt and do, but like we have now developed tools where you can actually capture that data and actually use it, and it's implemented. And what's amazing, like right now the public has access to MetaHuman Creator, mesh to MetaHuman. What's amazing is that we've started seeing people actually calibrate those rigs further, use more scans themselves, take those metahumans, edit them. We've even seen, I've seen, just browsing through the internet, like someone trying to do 4D as well, which is super cool. These are the things that basically enable us to, going back to Skydance, have the artists only think about what they want to do, and it just gets translated to the screen with MetaHuman Animator.
Yeah.
And everything.
So in terms of bringing that into the game, again, this is, I'm imagining that it's very dense, right? And again, you have to consider, I have to run this at perf. I need to make sure that it's fitting, the disk and all of that. How is that working out?
I mean, it's basically pretty similar to a MetaHuman rig. At the end of the day, the animation interface is the same. So if you really wanted to, you could copy that animation, put it on any MetaHuman, and it would do the same performance for that MetaHuman. And like all MetaHumans, there's just a series of LODs, and when you're really up close, you're LOD 0, and when you're far away or in gameplay, you're increasing the LOD. But just it holds up. I think we haven't had to do anything special to get it up to perf. It's just sort of out of the box what it is.
Marianne, I heard through the grapevine that you might have got a little performance in there with one of the is that right?
Yeah. With the iPhone, I captured a brief performance of, in the trailer, there's a soldier whose head gets smashed onto a typewriter. That's me.
That is really awesome.
And isn't that awesome? Like, they're having fun while working on these
Right.
things. Like, that's amazing to me.
Right. I mean, I'm always in awe of the gamification of game development.
Yeah.
So that's kind of pretty cool as well.
The turnaround speed, Marianne would be on a video call and she'd be like, "Hey, watch this," and she'd take a minute, just record herself, and then import it into game, and 30 seconds later,
It's
we're like,
so fast.
there.
It's
so
crazy.
fast.
Yeah.
And it's so easy.
Yeah. I like to say, like, a Datsun 210 that you used to have a long time ago, you really had to drive it, right? And now you have these Porsche or something else, and I don't think that no offense, the drivers don't have to be as good as the driver of the Datsun 210. And I'm feeling, and it's not that people aren't as good, it's that they can be so much better, and the scale at which you can do things. I mean, that's kind of what you're saying. It's like you're able to get, I mean, animators are actors, right? You're getting that across, and it's, I don't know, it's just amazing to see all of this starting to come together. So there aren't the creative blockers, right?
it's not just the speed of iteration, just also the quality. Like out of the box, we've seen facial solves in the past where you get the puppet kind of mouth, but capturing what we've seen in MHA, you're seeing all the lips roll, and the quality is just a lot better than what it used to be
Right.
in the past.
Right.
But also, we will not, as animators, capture performance and then put it on our Capture
Right, no,
America.
yeah,
It
of
won't
course.
work.
Of course.
It won't look like him. It
Yeah.
has to be him. It's just
Yeah.
like we're never going to create a different performance that he
Right.
didn't do.
Yeah.
I think that's an important point, because even if you wanted to, you couldn't, because like the fact that they were the ones that captured all of this training data, only they will drive that rig the way it like to give you that highest fidelity, right?
Right.
It's not like you now have their special sauce and you can do with it whatever you want and just generate performances. No, that rig is linked with that person. Like it's not, you can't have one without the other. And only if that person is the one doing that little, look up and down, or like, it's like similar with the table, like those little details. That's the only thing that's going to trigger those little details and all of that.
Yeah.
So it's very, and it's important for us, like none of that is getting, like the data, it's not going to MetaHuman Creator or anything, like nothing gets stored. It's just like special especially created for the performer themselves.
Yeah, I really appreciate that because again, there's nothing like there's nothing like a performance driven by a just top-notch actor. Like that is a craft that people study for their life.
Yeah.
The same as building an environment. It's something that whether you're a caveman on a wall or you're in there with UE and you're building everything, it's still that vision that you have that is actually driving things. And the other thing that I'm impressed with is that the vision evolves, and that's who we are as human beings. Our vision consistently evolves. So,
I did
evolve.
want to ask one
Yes.
question to Marianne. Well, the first one we brought into the engine was Gabe, right? In the trailer, that one performance, because I remember it was
right.
shocking.
Right.
When we very first previewed it, the amount of detail on his face and the way he expressed himself, I think my jaw just hit the floor. I was like, oh my God, this is like at that point I knew we were at like
When he
this is
was
something
against the
amazing.
board.
Yes.
Yeah.
Yes.
Yeah.
It's like I was like, we're onto something.
Yeah, that little
amazing.
twitch
Yeah.
that he had. Yeah.
Oh my God.
His face moves in like the most awesome
It's
ways
so
too.
yeah, it's so cool to see
He
that.
talks
yeah.
kind of like on the side of his mouth
Right.
a lot, and he's got so much volume in his cheeks, and the fact that we can see all of that,
Yeah.
it's really cool.
Yeah.
It's epic.
Hey.
Sorry, I had to.
Well, there's nothing to a performance without we want to make sure that our uniform is appropriate. So this also is amazing. So let's talk a little bit about the ML deformers that are here. So machine learning, being able to take in data sets and then bring them back and run in real time. Bonkers. Just absolutely bonkers. But maybe you can talk to me a little bit about what that process is. When do you use it? When do you not use it? Because there's, of course, the cloth physics in the engine, but can you tell me a little bit about that?
Yeah, so basically we use the ML deformer you can see on Cap's costume. So there's sort of different cloth strategies. For example, the cape on Black Panther was traditional chaos cloth. But for something that's somewhat form-fitting and you want to see wrinkles on it, the ML deformer stack is really what you want to use. So basically how we approach this is we take a lot of the workflows used in film, creating a cloth simulation rig. We set that up in Houdini in this case. I believe you could do it in Engine now. But outside of while you're in Houdini or whatever, you can do whatever you want with that simulation setup, whether it's leather, silk, or cloth. Then you pipe it through a training set based off of your animation that's in game. It's up to you how much or how little you want to train it. Ideally, you want to have enough coverage to cover the space that your character is going to move in. And then it's sort of a back and forth iteration. The system trains what it sees. You put in a pair of FBXs, which is just skinned, and some simulated alembics, and then Unreal can train how to recreate those wrinkles based off of the pose of the body. So you can once you have your data set trained, then you throw in almost arbitrary animation, and it'll recreate those wrinkles during runtime. It's actually pretty amazing.
It's super amazing. I mean, this means that like from the character side of things, you don't have to model in all those wrinkles. You can you can let them be, actually look like the proper wrinkles and actually animate.
It gets rid
properly.
of the baked wrinkle look and sort of a stiff video game look that you might see in sleeves or
So they don't have to
around
look
the
like
pants.
Little figurines or
Yeah.
like
Yeah, they don't have to look like
action
little
figures.
action figures anymore. Yeah, and you don't have to do like the normal tricks and things like that anymore as well. It's like it's there. It's awesome.
And the other thing that I think about this is seeing this. So what I'm getting from this is you don't use this everywhere, right? You use this right now for this part of it. Or what has been released, you've used with Cap, but you use other things in other spaces. Yeah.
Yeah, I mean we only have Cap right now just because it's It's early in our development, but I mean, we plan on having more. There's nothing really, I mean, performance-wise, it's actually extremely fast. So we would expect to see this, not just in cinematics.
Well, I think we are about to come up on the hour, and I would like to thank all of you for being up here. I have to say, I want to hit, you know how in Assassin's Creed you sit down and you say pass time? I'm ready to sit down and pass time till I can get my hands on this game. So thank you so much, and we will be watching you guys and want to wish you the best as you do this, because I think you guys are going to change the game of games. So thank you.
Hello and welcome. My name is Frederick Nielsen, and I'm a lead technical product manager in the Unreal Engine, but I'm also an animator, and this means I always try and look at the product from a user's perspective. So we are here to give you guys an inside look into how we made Lego Fortnite and what we went through as a team, both technically and creatively. For the first time, one of our games was fully rigged and fully animated in the Unreal Engine. This is a real milestone for us, and it means we have been able to rethink a lot of our workflows and keep our artists working in the same environment that they're also playtesting in. Joining me here is Jacob Buck, Technical Art Director, and Scott Lemmer, Animation Director. And with that, let's just dive right in. Jacob, why don't you tell us how you got involved in this project?
Yeah, it was just about 2 years ago now when I first heard about Lego Fortnite. At the time, I was on special projects finishing up a talk on destructible vehicles. I was reflecting on my time on the project, and I knew at the time that control rig was the future of rigging. Its node-based workflow and VM for execution opened the door to rigs that I didn't even think were possible before. I really just couldn't see myself rigging anywhere else. Control rig had multiple internal projects pushing on it. It was being used by metahumans, special projects, and Fortnite. I knew control rig was production ready, but I'll be honest with all of you, I also knew that animation engine had not been pushed through the paces like control rig had. But Epic is at its best when artists and developers are working together. And animation engine really just needed that perfect project to come along. Then it happened. Right about the time I was finishing my tech talk, I was lucky enough to hear about Lego Fortnite. I knew from the start that the project was the project to take animation and engine to the next level. The project was perfectly suited for this goal.
Yeah, it definitely was. It was a perfect project. Scott, you want to talk about animation a little bit? How did you get involved in the project?
Yeah, sure. I got involved with the project pretty early on. I was just coming off the Collision event on the Fortnite team when the Lego project kicked off. And the initial scope of the animation was pretty simple. The style really lent itself to proving out a new piece of software for the animation team. As animators, we really loved the style of the Lego movie and how they're using stop-motion animation. We loved the humor that they would put into their choices and how they stayed true to real-life materials of not bending, scaling, or deforming any of their characters. And we needed to test out to see whether or not this was actually going to be possible in Unreal. And we wanted to challenge ourselves to see if we could actually hit that style. So this is actually the very first animation test we did fully in Engine. And this was done by an animator by the name of Ed Fernolles. And he was the very first animator on the project. And with the success of this test, it let us know that it was actually going to be possible to animate in the engine.
Yeah. At this time, we were heavily iterating on the rig. I got to work with Fred and Ed quite a bit, just prototyping stuff out. We're figuring out which direction we wanted to go with the face at this time, and we're just building out the initial set of animation tools.
Yeah, it was a really fun time. Brainstorming what kind of features we want in the rigs and what kind of tools we want to build. Even getting to do some animation tests here and there, which is always fun. Scott, I think you brought some tests, right?
Yeah, so these are some more of the early tests that we did in the engine just to explore that stop motion style. So we were testing gameplay, social sim, even transferring emotes over from the Fortnite characters onto the Lego minifigures. And these tests were successful, but over time, our style eventually evolved. As much as we really loved the look of the stop motion, we found that as we were play testing the game, people were getting motion sickness, including our very own Jacob Bach. So eventually, the style evolved to more of a fluid animation style. And there was also some other considerations and reasons why we did this. Everything else in the game was running really fast. The entire world and other elements in the game were running upwards of 140 frames a second on high-end machines, while the main player was only running at 12. So we found there was a disconnection in style, and gameplay felt like it was missing some visual information. So the style evolved, and we moved to this more fluid motion style, and that seemed to solve all of these concerns for us. The team really started small. We only had one animator, but the scope of the project just continued to grow over time, and it's a living game that we're constantly updating with new content. More content meant the need for more animators, but to get more animators involved and working in Unreal, we needed to really make sure that we had familiar tools and a familiar workflow to pull it all off.
Yeah, we wanted to create a rig that was intuitive to use. Control rig allows you to make these control rig shaped libraries that allow you to turn any static mesh into a control. This allowed the animators to click anywhere on the rig and just manipulate it.
Yeah, and selecting controls this way is incredibly fast and intuitive for us to select characters and controls with. And every control is just right there at our fingertips. It's right there in front of us. So when we're interacting with the characters, it feels like we're sculpting the pose rather than just like slowly chipping away at it.
Yeah, I hadn't really seen anyone do that yet in Unreal. So, obviously because the characters weren't deforming, it made this much simpler to implement. Whatever we can do to keep the artist in their viewport closer to the characters will always kind of make the tools feel more natural and fluid, right?
Absolutely.
Control rig gave me a flexibility that I never had before with a DAG. What appears like a simple control to animators can contain complex rig logic under the hood. And the result of that is that you end up with a rig that's not only easier to pose, but it's also intuitive to use.
Yeah, and even though these controls were simple, they actually gave us some really advanced ways to pose that were completely unavailable to us with other software. Yeah, and they're actually set up in a way where it stays really true to the real-life materials that the minifigs are made out of, and it also helps keep our characters on model.
Proxy controllers were another eye-opening moment for me. They are non-keyable controls that allow you to manipulate other controls. Since these proxy controls fire in their own event stack, you can create complex manipulation by just rotation. In the case here, we have what I call the body rocker. Every tick, the proxy controller calculates the pivot to use and is able to rotate and translate the body around that pivot. Proxy controllers were a really big part of removing complexity from the rig.
Yeah, and instead of having to rely on these custom controls that would deal with temporary pivots, these proxy controls actually gave animators access to multiple pivots that were built right there into the rig. So posing the characters actually feels like it's actually like interacting with solid surfaces and makes creating convincing contact fast and easy for us to achieve.
Yeah, this was such an exciting time for development. We really started to feel the power of what we could achieve in here with these control rigs. And it felt like we were charting new territory, and our heads were exploding with all sorts of ideas on how we can use these new features.
And with having locked down the animation style, in addition and combination with these new rig tools and features, it actually really made it super compelling and exciting to be animating a full game in Unreal.
Actually, I kind of remember that story a little differently. Scott, you called me up and you were like, I don't know, are you sure we can do this? Is the tools ready? Can we handle this?
Yeah. Initially, we were pretty hesitant, I'll admit. We already had existing software, tools, pipeline, workflow that we were comfortable with and that were working really well for us. So we were really wondering if this was going to be possible and better than what we already had. And we knew if this was going to work, we needed to make sure that we addressed some of these initial concerns.
Yeah, absolutely. Since we knew what the animators needed to do their jobs effectively, and then we started taking a closer look at the scope of the project and the deadlines. It honestly made me a bit nervous as well. But we always went back to what Jacob said earlier, that there's no better suited project than this. There really wasn't. So Scott and I chatted more about the plan, moving forward and how we could best support this project. And we went straight ahead.
Absolutely, yeah. And we knew that for this to actually work, it had to be a comfortable and just seamless transition for any animators coming from other software. And fortunately, after talking with Fred, a lot of those concerns were smoothed over. And we realized with the continuing development and new features that were on the way, we just felt a lot more confident and optimistic that this was going to work out.
So this project quickly became our top client for feedback to both the rigging tools and the animation tools. We gathered lots of feedback from the animators. What kinds of meetings do we have to put into place? What kind of Slack channels might we need? How do we handle onboarding? So first we focused on quality of life and some of those initial pain points that the animators were feeling. Even simple things like selection and manipulation and missing hotkeys, that kind of stuff. So first we then started working on improving some of the other tools, like more advanced kind of tools, space switching and constraints and snapper tools, even some of those tween sliders that the animators would be used to coming from other tools.
Yep.
I remember several meetings with Scott and the animators where they were a bit frustrated because I'd demo all these fixes and new features, and they knew they wouldn't have them yet because obviously a project of this size, we had to be pretty cautious on taking big new engine updates. So how do we solve that? Well, we ended up moving some of our development efforts directly onto the game, and this meant that the animators had quick access then to some of these fixes and new features, and that made the world of a difference. But this obviously came with its own challenges because things could break, and they definitely did. But when issues came up, we quickly pivoted, and we were able to kind of fix things pretty quick. So.
Yeah, there was so much work to do and just not enough people to do it. So we took a two-pronged approach to get the tools out to the animators. The art team on LEGO Fortnite worked very closely with Fred and the engine team. We divvied up the efforts. Core provided new functionality, and the art team focused on building tools for interfaces and workflows.
Yeah, our appetite definitely far exceeded what we could achieve in time, so this was really the best approach moving forward.
Luckily, Unreal provides intuitive frameworks for building tools and creating rigs. Control Rig and Blueprints both share a node-based interface and will be familiar for anyone trying to learn them. Editor utility widgets are at the heart of building interfaces in Unreal, and I feel that so many people just do not understand how powerful they are. They make building interfaces accessible to anyone that knows Blueprints. We know pipelines are very specific to studios, and editor utility widgets allow a studio to build a pipeline tailored to their workflow.
Yeah, whenever we add any kind of new feature or functionality to the engine, we also always have the ability to expose their API. So tools like these can be built around them, to either automate or script how they're being used.
Kind of to highlight some of the power of these editor utility widgets, I want to show you a couple tools. Animators needed a window into all their data that they were going to create in the engine. The animation browser was created to give animators a central place to view and open their animations. We also wanted to tackle file management. This tool took the guesswork out of naming and organizing files. It even has a built-in versioning system, so every time an animator saves a file, it gets put into a repository that they can recall later. This tool was fully built with Blueprints.
Yeah, and file management is very different for animators. So getting the anim browser was a crucial tool for us as animators and getting those animators into working in the engine. When they're working in the engine, it actually helps us out a lot because they become a lot more familiar with the systems and how everything's implemented. And it also gives them a better understanding how it all comes together, and as an end result, we get much better animation.
Linked anim sequences were also critical to our workflow. When animating a character in a level sequence, the animation data is automatically baked to an animation sequence on save. This provides a seamless workflow for animators who just save their scene, and the animation is automatically updated for them in the engine. The animation browser took full advantage of these. There's another utility widget I'd love to share with you all. This is an animation picker that was built on LEGO Fortnite. This modular picker was designed to make animators feel at home. Under the hood, it allows any artist to take the full power of blueprints and build a custom picker for any character or creature you would like. But it also allows animators to customize the picker and the widget itself. It exposes quick access to handy features like mirroring and flipping, and it also provides access to Unreal's built-in pose library.
Yeah, and the fact that we could now pan and zoom and marquee select, all the things that animators are used to be able to do. We could customize the picker, we could add buttons to our liking. That made it really familiar. And having the picker, as well as easy file management, that actually kind of unlocked the door to being, really accessible for animators animating in the engine. Anyway, there was still a lot of work to do. Even though we got some of those tools out of the way, we were animating an entirely new game from scratch. And another huge initiative we had was we were supporting Fortnite emotes in LEGO Fortnite. And this was an interesting and challenging process because minifigures, as you can see, have very different limitations than a humanistic character. They've got different proportions. They don't have elbows, they don't have knees, wrists, they don't even have fingers. So it was far from just like an easy, seamless one-to-one translation. We had to come up with actions that would have the same intent and feeling as the Fortnite characters. But on top of that, we also had to make sure that our animation worked with many different outfits that Fortnite had to offer.
As Scott just said, Fortnite has a large catalog of outfits. We're in the process of converting them over to LEGO. To build out such a large set of outfits, we're using Mutable to combine the meshes and textures at runtime. To bring all these outfits to life, we wanted to minimize the amount of custom animation needed for each outfit. The minifigures share one animation set, and to get variety, we are using runtime control rigs to procedurally add it where needed.
Yeah, and since it's all working at runtime, and they're all sharing that same animation set, it means we can test and iterate our animation using any outfit we want.
For the face, we took a texture-based approach. Before landing on this, we experimented with a wide variety, but we ultimately came back to textures. It's performant, it stayed true to the materials, and it supported that snappy style of animation that we were going for. This also had the added benefit where we could just swap out the face atlas and get a different outfit pretty quickly. We're using a total of 120 animation curves to drive material parameters, so the system is material agnostic. At the heart of the material, it's just transforming UV space. And because of this, we can get a rig working across a wide variety of models, such as Peely. We even implemented a UV warp that would liquefy parts of the face, but we ended up not needing it because the rig was flexible enough without it. Certain outfits also have the ability to enable a runtime control rig, which procedurally animates the beards and the mustaches. To do this, we're taking advantage of control rigs' data-driven approach. Using data assets, we are able to embed data on a skeletal mesh and read that data back into the control rig. This is incredibly powerful. When you combine external data with the ability to procedurally generate controls based on the incoming hierarchy from the skeletal mesh, you can create a flexible control rig on any mesh that's placed on. A simple example of this is how we're using a single control rig for the vast majority of the props on LEGO Fortnite. Control rigs were also being used at runtime on our creatures. Quadrupeds present an interesting challenge when walking on uneven terrain. To get the creatures to adapt to any terrain, we're using traces to detect the ground plane, and then we're adjusting the way the creature behaves on that terrain. This allowed us to adjust the chest and hip position based on where the feet and the head are at any given moment. We also leaned on control rigs' built-in profiler to make sure that these rigs stayed performant at runtime.
Yeah, it's been incredibly powerful for us. Slope warping has meant that it eliminates the need for any custom blend spaces or pose content that otherwise we'd have to provide.
So I want to put my product hat again and highlight some of the cool new stuff that we've been working on lately in 5.4, especially around animation authoring. So we've been working on new gizmos. So these are our manipulators. They're still experimental, but they're available for you all to try in 5.4. They have a new look and a style, and they also have a new feel. The proper indirect manipulation. They have a new parent space option in the viewport. So previously we only had local and world, so now you have parent. We've also done quite a few improvements to our sequencer, so where we not only improve the look and style of it, but also a lot more flexibility in how you can customize kind of what's available to you. Things that were hidden deep in like right-click menus are now exposed as columns and icons right next to the tracks and stuff. Our anim details, so this is our channel box. The previous version only showed transforms on like characters' controls. But now we've centralized showing transforms on anything that you may have added to your sequencer, including props, cameras, lights, as well as those character controls, of course. We've added a new selection system to the anim details window, which is fully synchronized with your curve editor. And we've fixed issues with just using those sliders in like the details view. This would be our anim details, but yeah, just kind of more functionality around that. We've added key status indicators, so you know if you have a keyframe on the current frame or not. And definitely more to come in this area. Our curve editor, so our sequencer curve view, we've also done quite a few improvements there. We continue to focus on quality of life, and we've been working on the performance of it. We've improved zooming and panning workflows, selection accuracy, even understanding like awareness of what curve type you're animating in. So keys before, it'll kind of analyze what curve type it was and continue on with that. Our constraint system has also been really overhauled. We rewrote the data model to save just into the level sequence for any constraints that you may have animated. But we also still support level constraints when you're not using the sequencer. We've reworked our evaluation engine to better handle more complex, like nested setups. And you can now even change settings on those constraints on creation. So you can turn off maintain offset or even constrain individual axes now. We have a new system that we're pretty excited about called layered control rigs. And this gives you a lot more flexibility in how you pose and animate on top of incoming data. So we're already using them in all sorts of interesting ways. It means you don't have to bake data down to the control rig to modify it. You can just add a layered rig and then just animate on top of it. We're super excited about these and getting your hands on them and seeing what you all do with them. They're pretty cool.
Yeah, and all of these updates are incredibly important. I mean, if we didn't have them, it would be impossible for us to fully commit to animating this game in Unreal Engine. And having all this work that has been done in one piece of software allows us to do this and animate in-game without any round tripping.
The rigging and character authoring side of the engine are also getting some big updates in 5.4. The ability to author a character in one place also has massive impacts for predictivity. Chase Cooper will be at the Learning Theater in Epic's booth running through all sorts of awesome rigging demos. Please go check them out.
So these are just a few highlights of some of the features that we are excited about in 5.4, but we've also made tons of other fixes and improvements. 5.4 Preview 1 is available today, so download it, play with it, send us your feedback. We do want to hear from you. Speaking of new features, Scott, I heard one of your animators found a pretty cool new workflow, happy accident.
Yeah. So actually, before I tell you what that is, let me just set up our workflow to give you an idea of what it was like up until this point. And as fantastic as it was to put aside the third-party software and completely animate in the engine, we were still slowed down a little bit by having to launch the game in Pi anytime we found something that we wanted to iterate on or fix. And what we would have to do is close down the game simulation, work on our animation, save it, relaunch Pi, wait for it to load, and then reset up the ability or whatever it is that we wanted to test. And it was still a process that would take several minutes sometimes. So what happened was one of our animators, Nick Beckstead, was animating away, adjusting poses and timing like he would normally do as he's working on his work. But he had found that he had unintentionally left the game running in the viewport. But he realized that his changes were already updated in the game. And we had discovered at that point that we were able to work and animate without ever having to leave Pi. So all of that back and forth was completely cut out. And we can now animate and play test our results instantly. And any of you that have worked on gameplay animation before, you'll understand just like how valuable that is to be able to animate and just see the results. You can play test the results instantly in game. And for animators, the seamless workflow is really just absolutely mind-blowing.
I wanted to thank you, Jacob, and your fabulous tech art team, and Scott, your animators, for being patient with us as we go on this journey together. And of course, our amazing engineers, both in the control rig team and the sequencer team. Obviously, we couldn't have done anything without them. And next up, I want to introduce Patty Walker to the stage to talk about motion matching. Thanks, everyone.
Thank you, guys.
Hello, everyone. Thanks for being with us today. I'm Patty Walker, Technical Product Manager of Gameplay Animation. With me is Samuel Rigamonti, Principal Engineer on Motion Matching's development, and Jose Villarroel, Lead Engineer of the Gameplay Animation team. We're really excited to talk to you about delivering motion matching to everyone. And we'd like to give some insight into some of the challenges and solutions we came up with as we ship motion matching into Fortnite and Unreal 5.4. Now, before I dive into all of the challenges, I want to start with some positive news. Fortnite Chapter 5, Season 1 officially shipped with motion matching running on all 100 players, all NPCs, and on all platforms, including Switch and mobile, which is something we're really, really proud of. Now, with that said, let's jump right into the challenges. Fortnite ended up being one of the hardest examples to get right with motion matching. Why? I actually originally thought the opposite. Fortnite prior to this only had 8 cycle loop animations. The entire player set was pretty tiny. How hard could it be to recreate that? It actually wasn't that hard. But we weren't trying to do just that. This is how a lot of people play Fortnite. It's a Twitch shooter with instant responsiveness. It's got 2 frames from full speed to full stop. Fully networked with 100 players and NPCs. It's established as one of the biggest games on the planet. And this feature was built by a small dev team with a short turnaround time. Most of what I just listed are areas where motion matching traditionally struggles to get to quality. And our goal wasn't to deliver the final version of animation quality that could be achieved, but instead create a framework where it started on a strong foundation that could continually improve into the future. On top of the struggles of just generally making a Twitch shooter look great, we also had some challenges early on with Unreal's foundation as well. Because Fortnite is completely capsule authoritative, brute motion wasn't an option to use to get back animation quality where we needed. Our default movement model in Unreal, the character movement component, is a bit rigid, and it wasn't as customizable as we needed it to be. And we lacked internal animation data and resources to help push and test the scalability of quality in the system early on. Then there were existing features in Fortnite itself that could greatly complicate how we used motion matching. Items like Icy Feet, where consuming this item makes the character slide around as if they're on ice. Or Hot Pepper, where the character's acceleration increases exponentially after consumed. And finally, Fortnite Creative, where users can manipulate the speeds and many aspects of the movement model on the fly to nearly whatever they want. Now, let's use Icy Feet as an example. This is what happened right out of the box when we tried it initially. As you can see, all of a sudden, motion matching got really confused on what to pick, with no data matching now what was being requested by the movement model. So, not so great. But it wasn't just existing features that we had to battle with. For Chapter 5, the Fortnite team introduced a giant moving platform, the train. And, like with the Icy Feet example, our motion matching solution didn't exactly work just out of the box. It became clear quickly that the train's velocities were also being piped into the player's capsule, causing a complete breakdown of selection or the idea of direction and speed. Now, on top of all these game-centric and Unreal-centric challenges, the system as a whole had to be extremely performant, memory-conscious, and simple enough for artists to use. It needs to scale to anyone's vision of how they wanted to use motion matching for their games. Right, and then the classic game development problem. While we've been developing motion matching in Unreal for some time, putting it into Fortnite wasn't initially on our list, nor was the timeline on our side. However, upon showing Fortnite our internal prototype, they got pretty excited and wanted to see it in the Chapter 5 release. This left us with about 3 to 4 months of development time and a few weeks of iteration time, which was not a lot. So, I've laid out all of the challenges that we kind of ran into. We had a lot of work to do. Now, I'm going to hand it off to Sam to chat about some of the solutions that we came up with. Sam?
Thanks, Buddy. Now that we understand the challenges we faced while developing our motion matching solution and the additional requirements specific to Fortnite, let's dive into the recipe we deem necessary, starting with some fundamentals. So let's add some context and terminology we can reuse later on. Motion matching is an animation technique that automates the transitions between nodes of a motion graph, where the nodes are sample poses of animation from a database, and the selected transition is the one that scores the best given a metric between two poses, where one of them is the query pose. In our implementation, the simplest setup consists in a character with a movement component running an animation blueprint with a motion matching node and a pose history node. The motion matching node will search a given database using a query constructed from historical information from the pose history node and a motion model prediction from the movement component. If the search selects something